Hello, it's Keith from Kinvert, and I wanted to make an example like story problem related to linear inequalities. So I just kind of made this one up. This is similar to the kind of thing that I'll see in my business, and especially because we don't really buy this type of software, but I've done consulting for companies where you recommend things to them and you want to see what the ROI is. But anyway, so imagine that you have a company and you're paying out $350,000 a year in salaries to, coders and whatnot. And there is a new software that you could buy that would make them more effective at their work, right? And you could effectively eliminate, say, $50,000 a year in outsourcing some contract work, or maybe reduce overtime, which I know that coders don't really get overtime, but you get the point, right? By buying the software, you'll reduce your yearly salary by 50 grand. Okay. The purchase price of the software is $75,000. You only pay that once, right? But the yearly cost, there's a yearly license of $12,500 per year. And what you want to do is figure out at what point is it going to, will I spend less, right? Because you're spending more up front because you've got 300,000 plus the 75 plus the 12, right? So it's definitely more than $350,000 per year, but your yearly costs will actually end up being only $312,500 over here, which is like $37,000 less. So how long is it going to take to pay off both this upfront fee and the yearly? Let's start taking a look. We're going to actually write this out as an inequality. So what we want to know is at what point is our current cost structure going to be greater than our new cost structure. Our current cost structure is 350,000 x. X is just years, right? X is years. How many years? 350,000 x. At what point is that greater than, and what's this going to be? We're going to have 75,000 because that's a one-time investment plus, and then we're going to have 300,000 plus 12 because these are both per year, so this would be 312,500, right, x. At what point is this left-hand side higher than this right-hand side? Because this right-hand side will start off higher because you're putting up that $75,000 investment, right? So what does this kind of look like? I know that this isn't the perfect graph, but we have something like this, where this one has a bit of a y-intercept, but a more shallow, let me color these. So I'm going to undo this line. I'm going to call this one green, okay? And I'm going to call this one purple, if that makes sense. So the green line is going to start off higher, but it's got a lower slope, right? Because you got a $75,000. We'll just put that up here like these are multiples of 25,000 or something, and I'm very much just drawing this loosely here. And then this one has basically no upfront investment, but it's got a higher rate, right? And we want to find at what point these cross. Now, believe me, it's not just going to fall there. This I just drew by hand. This is not it. But I hope you can visualize what's going on here. You can see that if this is y equals mx plus b, the m here is 312 versus 350. So you can see this one's going to be steeper. Let's just start dumping in and doing the math here. So the first thing that we want to do is get all the x's on this side. We're just solving this like a normal inequality. So what we're going to do, we're going to subtract away this 312 from each side. 312,500 x. We're going to subtract this away from both sides, and that's going to cancel this out. So now we're going to have 37,500 x. At what point is that greater than or equal to 75,000? Right, because really the only difference between these two, like that we're looking at here as far as yearly, is you're saving $37,500 per year in salary, right? So this is $37,500 in salary per year that you're saving, and at what point is that amount, in how many years will that be greater than, and how long will your savings in salary be greater than that $75,000 upfront investment, right? So now we can just go to the next step here, and we divide both sides by 37,000. I know these are big numbers here, and divide this side 37,500. And what do we end up with? So this is just going to be x, and x is greater than or equal to 75,000 divided by 37,500. That's 2. So it is in 2 years that it will have paid itself off. Okay? A follow-up question that a teacher could add is, say, how much money will you have saved? How far ahead will you be, right? In 4 years. So in 4 years, what is the benefit? Does that make sense? In 4 years, how much money will you have saved by doing the investment instead of declining it, right? And this is related to ROI, like, what's your return on the investment here? You've got not only the $75,000 investment up front, but you've also got this recurring cost of $12,500. And so the original question was, how long will it take to pay itself off? Or, when is your break-even point? And that is in 2 years. And then after that, you can see that you're doing better, because this is cost, right? This vertical axis here, this is really your cost. Okay, and so you want to minimize your cost. And that's what we're doing here. By doing the investment, you are minimizing your cost after 2 years, right? But before 2 years, you're money behind. For the first 2 years, you're money behind. So I hope this makes sense. This is a real life thing that you could do. This is very applicable, right? There's software in the engineering field, like 20 grand a year for like some of the top end CAD software. And it really can be a big productivity gain for the engineers. And so this is a very realistic scenario here that we're looking at. Now, that said, there will be little things. If you change software, the engineers have to be trained on it. They'll have reduced productivity during that time that they're being trained because they're used to the old software, right? I just want to show you, this is pretty close to real life here. And this can be solved with a basic linear inequality, pretty straightforward. I hope this made sense. This is Keith from Kinvert going over a real world, real life, example where you can use a linear inequality to solve an actual real world problem. This is part of our online course for Pre Calculus and another in algebra. There's a lot of overlap between Pre Calc and algebra. This example problem is going to be put in both. Obviously, not everything we're putting in the course is going for free on YouTube, but I hope you can benefit from this. If you're interested in learning more about the online course, we'll have some information in the description below. But anyway, hope this helped you, and we will see you guys in the next one. Bye-bye.